you have made it to the last lesson of this part of Unit 4 and the last lesson of Trimester 1. So today we're talking about inverses of functions.
So inverse of a relation is when the ordered pair of relations are reversed. So the inverse of 0, 7, 4, negative 3, negative 3, 4, negative 2 is 7, 0, negative 3, 4, 4, negative 3, and negative 2, negative 2.
So for example, if we're given the relation 1, 2, 2, 4, 3, 6, 4, 8, we want to know is the relation of function. In other words, if we graphed it, will it pass the vertical line test? In our case here, yes, it will. And if we asked you why and how you know that, it's because there's only one output for every input. Now, what is the inverse of the relation? We're interchanging x and y. So that means my new relation, the inverse would be 2, 1, 4, 2, 6, 3, 8, 4. And then we want to know, is the inverse a function? In other words, again, does it pass the vertical line test? In our case, yes, this one would, because there's still only one output for every input. And then finally, we want to graph the two relations. So in blue, I'll graph the first one. 1, 2, 2, 4, 3, 6,
and 4, 8.
8. We can graph that. And then in red, I'll graph the other one. 2, 1,
4, 2, 6, 3, and 8, 4.
And we'll talk about how they relate to each other now when we get into saying, okay, now we have a function. So we have the function f of x equals 4x minus 5.
So step 1 is replace f of x with y.
I know some of you are going, well, then why did we replace y with f of x to begin with? Just go with it here. So we rewrite it, y equals 4x minus 5.
So then at step 2, interchange x and y.
So now that means I now have x equals 4y minus 5.
Step 3, solve for y.
So to do that, we're going to add 5. And we'll get x plus 5 equals 4y. Then we will divide both sides by 4 and get y equals x over 4, or 1/4 x, plus 5 fourths.
And step 4, replace y with f1 of x.
So f inverse of x. So we got f inverse of x equal to 1/4 x plus 5 fourths.
Step 5, graph the y equals x.
We're going to graph the line y equals x, and there's a reason for this. So I'm going to graph this dotted line, and it just connects your two corners of each other.
Step 6, graph your function and the inverse.
So I'm going to start with the function, y equals 4x minus 5. I'm going to graph that in blue. So 4x minus 5, we go down 5. We go up 4 over 1, up 4 over 1, up 4 over 1, and we connect our dots. And then I'm going to graph the other ones in red. So 5 fourths. So that's 1 and 1/4. So 1 and 1/4 is right here. And then we go down 1, 4, 4, down 1, 4, 4, and we, that's a little bit off, but in the picture.
And step 7, check to see they're symmetric about the line y equals x.
Which is why it is so important to make sure you're using a ruler, unlike what I have done here. But as you can see, if I have them all accurately drawn, you're going to see that if you angle yourself so that way the line y equals x that's in pink is vertical, turn your head, you'll see that they're symmetric about each other. So basically what we want you to make sure you understand is when a function and its inverse are graphed on the same coordinate plane, they are reflections of each other over the line y equals x. This is very important. Hint, hint, hint. So now I want to just algebraically find the inverse of f of x equal to 5 minus 3x over 2. So remember, first step is to rewrite it with y instead of f of x. So y equals 5 minus 3x over 2. Second step, switch x and y with each other. So now we got x equals 5 minus 3y over 2. Then solve for y. So multiply by 2. So now we have 2x equals 5 minus 3y. Then we subtract 5, and we get 2x minus 5 equals negative 3y. Then divide everything by negative 3, and that gives us y equals negative 2/3 x. Negative divided by negative is positive, so plus 5/3. And then finally, to complete your full answer, replace y with f inverse of x equal to negative 2/3 x plus 5/3. A lot of algebra. That's about all it is. So now, here are two functions. I want you to find the inverses of these two functions. And as always, questions come with you to class.